Hey folks, welcome back to another midweek machining video. This is midweek machining number 8. In this video, I'm going to repair the threads on that cylinder block for the KZ1000, the 1980 Mark II. In a video, you'll see the problem with that. That predates this one, or actually precedes this one. In this video, I'm going to go over quite a bit of detail on doing a Time-Sert thread repair in a hole that's below the surface of the material that you typically see a thread. So it's a little different, and there's some shape to the bottom of the hole that gave me a little concern as to whether or not the Time-Sert was actually going to be the right repair for this, but it ultimately was. Watch for the other video that's coming out on number 2, the video 2 that is, where I actually reinstall everything on the KZ1000 and see how we did. Till then, let's get right to it. All right, we're up on the 1, 2, 3 blocks. And again, these are new ones. I restoned the table too before starting, and I wiped off everything. I like to wipe it off by hands, kind of machine this thing. Get the feel for everything, make sure there's no dust on it and crap. And you can feel whether or not it's flat because it'll start rocking if it's not. And this thing's dead flat. So we're going to re-indicate at least a little bit of it just to make sure. I already have 2 T-nuts rather into the center T-slots. One about there, one about there. So I'll go get some studs. You said stud. We'll run them down there and get them up to the appropriate height. Just a couple of clamps across. We don't have to clamp hard, but we got the blocks directly underneath the clamping force. For example, I wouldn't want to put the clamping force out here or the blocks out here if we were clamping in here, or again, vice versa. So we're going to be clamping directly down on top of it. And by the way, I forgot to mention earlier, I did take this cylinder block and flip it over and indicated the bottom of it, the mating surface with the crankcase, and that is dead nuts flat as well. I use that new roto indicator that I have. It's really, really cool. I changed the setup a little bit because I realized I had the casting flip back around the opposite way I wanted it. This is the hole that needs to be repaired because remember, it's on the left side of the bike on the engine. This is the rear of the jug because here's the tensioner opening. And I had to push it over because I did a quick test off camera. Although I can reach both ends in the same setup, it's not very comfortable. You have to have that table way, way off. And in a mill like this, I don't really like doing that. I like to work more toward the normal operating ranges would be the best word of this thing, the way it's used to working or designed, you know. So what we're going to do is just snug these down. Doesn't have to be tight. Oh, by the way, I have some aluminum strips underneath here, parts of beer cans. You know, it may look like I'm really going through a lot of hassle here to just fix a couple threads, or one thread in this case, but there is a reason, and we'll get to it here in a moment because I'm going to show you some detail of this hole in here that kind of gets you up to speed as far as my interpretation of what really needs to be done here, all right? So anyway, we're secure. That's definitely tight enough. That ain't going to go anywhere. I mean, it's not like we're hogging off material or boring a hole or something. We're just going to fix a thread. So let's go ahead and move the table over. But before I do that, I want to go too far. I'm going to set that roto dial indicator up. I was mentioning before, I think. Just indicate in the top here a little bit. I just want to double, triple check this is parallel with the table and perpendicular to the spindle. The sucker is pretty neat. Magnetic base is like bitchin'. Doesn't articulate quite as much as like a Noga, but Noga Flex. I mean, this would be really bitchin' on a Noga Flex, but you know, you can still get you know, pretty good results in whatever you're doing. See, this is the beauty of it. This is the roto part of it. You can rotate the head of this indicator around anywhere you want, and then just tighten it up. So I'm just going to snug this guy down, and then, like I said, you can see over here, pretty cool. The head rotates, and so you can turn it anywhere you want. I really like this thing. I saw it on A-Bomb 79's channel. He was doing some creative indication of a part he was machining, and I'm like, oh, I gotta have one of those. I gotta have me one. We'll just double check, you know? There's no harm in double checking. The Y looks good. I'll drop it over this hole to make sure that we are actually indicating. Yep, see? And the X looks good. So that's all I need to do. I want to make sure I'm square with that anyway, but that just gives me a good idea of what the casting is doing as far as squareness to the table. All right, I got you over the hole, but a little bit at an angle because I kind of wanted to give you a little bit of a side shot here. because this is what we're dealing with as far as the hole goes. Now, as you can see, this is the counterbore here for where the pin goes. And I'll discuss the pins here in a minute. Now, down below that, you can see there's a little ridge right there. And that ridge is where the pin bottoms. Now, if you look down a little further, you can see inside this hole, the bottom of this hole is not flat. It's not like somebody went in there with an end mill. It's tapered like it was the end of a drill bit. What I'm thinking is when they did this, they drilled it out with a drill bit or some other somewhat round nose tool. Maybe they plunged it with an end mill that has got that kind of profile or geometry on the end of it. Then they came in afterwards slightly bigger with a tool to make this area for the pin right there up to that little step. So essentially they left this step and down here for where the pin ends. So the pin terminates right there. And then your threads are below it. So the thing that I am most concerned about with a hole like this is the material I have left to work with, because it is kind of an unusual hole. It's not like it's flat on a casting, a big fat casting, and you got no limitations. So the one thing I was concerned about was how much meat is down here in the side of the block here for the material left over that we're going to be drilling out, because we're going to be taking some material out. What I did was I reached in here with Starrett 120s, and what you end up getting is, let's see, it's about 540, 545. It's a little more difficult to get it up higher because this tapers into the block. Down here it's an actual true diameter you can get, but it's basically the same up here. So about 550, let's say. Then I take a look at what is the largest thing that's going to be shoved into that area once we machine it out. That would be the tap. This is the Time-Sert tap. So if we measure up the Time-Sert tap, what is the major diameter of that? Is 285. So we got plenty of material in there, unless there's some inclusions in the casting or something, which we can't foresee, that is going to be left for material for us to do this repair. Now, the other consideration in a hole that's recessed like this is whether or not shit's going to fit down in there that you want to put in to do the operation. This is the counterbore tool for the Time-Sert. So will this fit down in there without screwing up this area of that counterbore for the pin? And you can see that it fits, but it barely fits. It's close, but it does clear. Right now, as far as pins go, this is the original pin that came out of it. On one side or the other, doesn't matter. And they're pretty nasty, they're pretty messed up. And I've cleaned this up a lot. This thing was really rusty. The hole was all rusty. So I don't know what the hell they were thinking when they put these back in. They must have had to hammer them back in. Because although it fits, it's not great. And you can feel that it's out around. See this, how it rocks? That pin is out around. So yesterday I went over to the lathe and said, "Hi, Mr. Lathe." And I took some, I think 304 stainless, some 7/16 bar stock, and I machined some new pins. Are much nicer. All right, and when these go in, you got to have a slight amount of clearance on these, but they shouldn't be, hard to put in and be rocking because it's out of round. So this, I think these will work a lot better. So I'm happy with that, and the length is the same. I use the DRO to calculate the, measure and duplicate the length of it, and the diameter is the same. So like I said, this is really the way it should go. The inside of these counterbores are just not in good shape, and that's from people taking out of round pins like this and beating the shit out of them to get back in, and that's not good, plus all the corrosion that was in there. This is the pin we're going to end up using. I have a duplicate for the other side, so I'm happy with that. So the other thing we got to consider on this, because that bottom of that hole is kind of tapered, you see that taper like the end of a drill bit. I'm not sure how this counterbore is going to deal with this, because remember, it's tapered down in here, probably the end of a drill bit. And so it is a little bit more, not really flatter at all up in here. So this is really the sidewall of it right there. And then it starts to taper right there, right at the edge of the screwdriver, and then goes down. So I'm not sure how this counterbore is going to deal with that, because you can see it goes down so far and then it'll stop because it won't cut anymore. And the geometry in this to do that is these flats right here. You see these flats that are right on the edge of it right there? So these flats are what it bottoms out on. So what I'm thinking about is we might just touch off on that as far as the counterbore goes. Instead of going full depth, we'll just, and what that'll do is it'll square this surface up. Really what the counterbore does also, besides give a relief, is to square up the mating surface of the insert. If we kind of just touch off on that and take a little bit off with this counterbore tool, I think we would achieve the same thing. We would get at least some clearance, because we don't really have to worry about the vertical aspects of this. There's plenty of clearance down here. As long as that insert is below this edge right here, then even if the insert stopped about right here, we'd be perfectly fine. So I'm going to rearrange this so you can look straight down and take a look at another concern. All right, so I have a backlight looking from the side of the hole where it penetrates down through, and you're looking straight down at it. And you can see that that hole is not exactly round. That's because there's some remnants of the thread left. So I think the drill bit is stout enough where it'll go in and clean that out, but that's another consideration you'd have to do, because the thing is the drill bit's going to want to follow whatever the profile of that hole already existing is, but it's a very short, stout drill bit. Interesting, it has a like a tap driver on it. I never saw one like that before. And so it should hold that up pretty good. You know, like I said, these are the things that you look at when you're dealing with a precision hole repair. And again, I mentioned before, I believe, I'm not trying to overcomplicate this. I mean, when do I ever do that? Because what we really have to do is we have to accommodate for the fact that this has got to be in the right position, mainly because of the pin. So if we take this new pin, for example, we put that new pin in, you see how much less room we have now? So if we're off a little bit, so let's say we're in there but we're crooked, and you can see how much of an impact that would make when you include the pin into the equation, because there is just not a whole lot of room down in there. And so if the hole was off to the side a little bit, in other words, let's say it was square with the surface but it walked off, then again we have the same problem with that. We have the same problem with the fact that we're gonna be interfering with the hole, because I made this hole exactly the same as the ID of the other pins, which is a clearance hole for the M6. I'm not sure if it's a 6.5 or whatever it is, but probably about a 6.2, I imagine, millimeter. So just a little clearance for that. The main concern I have as far as accuracy goes is to make sure that this all lines up, and when you put the bolt down through the cylinder head into it, it doesn't either hit the side of the pin or get cockeyed and try to go in and gall the threads out. That's the whole reason for dealing with it in such an accurate and precise manner, is putting it on the mill here, because I just don't see another way to do it where we can verify that everything is really accurate. But we do have a good amount of meat here. I believe everything's going to fit, but we got to be spot on as far as the center of that hole for this counterbore tool to hit. Now, we don't have to use the counterbore tool. We can just drill it, tap it, and shove a insert in, and just let the insert find its deepest part where that little flange is going to be hitting the top of this. But again, I kind of want to square up that that surface down there, so we don't necessarily have to go full depth with this. So I think that helps to explain why I'm going through all this, as far as making sure that this is going to be proper as far as an accurate repair goes. That's the only reason why. I mean, I think this hole in particular, because of it is a little bit of a different hole, being it's counterbored and it's a pin locating hole, then I would say that's the reason why. So let's move on with the repair. The next step is we're going to indicate this and get to the exact center of that. I just have a part of an old indicator in here, which is part of the indicator that I'm actually going to be using, that best test from Brown & Sharp. And all I'm going to do is just eye this in. All right, that's close enough for government work right now. And we just got to put the best test indicator in, which I got right here. A coaxial indicator would be much more appropriate in this situation, but unfortunately I ain't got one. So basically what we're going to end up doing is just going around and making sure this is 0, 0. And I know you can't see the whole thing, but once I get it zeroed in, I'll kind of move around with the camera and you can see. And how you want to do this is essentially quadrants. You know, X and then Y. So what I'm going to do is I'm just going to do the X right now, which is side to side. All right, and let's put it on 0 over here, and then we'll go ahead and go over to here, see where we're at. That's coming up on 0 as well. We're almost perfect as far as the X goes. Now we're going to come around to the Y. Why? Because we want to, and we can see we're negative. So all we have to do is bring that back about half the distance. What is that, about 7 thou? And that will bring off your X a little bit because of that, like a cosine error, because you're working on a curve. So right now back here it's about +10. Now we're going to go ahead, and this one's to the negative. We're going to go and bring this X back over about half the distance. Like I said, a coaxial indicator is the way to go on this. Let's zero out on that because we're pretty good on the X right now. Let's just concentrate on the Y. So let's verify. We got 0 on Y there. And a couple of tenths on the back, so that's, I'll consider that good. Okay, so here's that side of the hole where you couldn't see before. Here we are again. We're within a couple of tenths, so I would say it's pretty good. So anyway, I'm going to check this hole a little deeper and a little more shallow just for the hell of it, off camera, but you get the idea what you got to do when you're coming up with precision like this. I went a little deeper in the hole and got a little bit different reading, so I would kind of trust that as a little bit more accurate than more toward the surface. So that's what I've reset. There's only a couple of thou and it was on the Y-axis, but we got that dialed in now where she's pretty much 0, 0. Now I'm going to zero the DRO X and Y. Now we know where we're at, so if we got to move for any reason, we can just come back to that 0 and we'll be in the same exact place. So anyway, that's it. Takes a little while to do, but like I said, I like accuracy when it comes to jobs like this, and I think it's pretty much critical in this situation. All right, table's locked. Everything's locked. DRO is zeroed, and we're going to go ahead and just shove her through. I only want to go down to, I'm going to clear this entire thing out, because it does extend down through it. Why not, after all, you know? That way we don't worry about any bottoming. So I just got to watch it when we come through, but it isn't very long of a drill bit, so I think we'll be okay. Contact. Not going to take much. The beauty part of this is I just measured this up, and the tap drill for a Time-Sert M6 is the same size as for a helicoil. So if we decided to make a change and go, and you know what, I'm just going to do a helicoil, we switch over to a tap right now, it's the same size. So we're not out of the woods yet, but I don't believe we're going to have that problem. Okay. I'm going to switch out to this counterbore tool, just see how it fits in there. Because right now it should fit. Drill bit's in the way. It should fit directly because that's a kind of a precision tolerance between the tip of that and the tap drill. Make sure it's running square. True. It is. Before I spin it, I want to make sure it goes in. I'm just going to kind of dab at it. That's about it. About it. That's all we need. Let's take a look at it. So there's your counterbore down in there a little bit. I dabbed at her just a little bit more. See, that looks good. And we're dead nuts in the center. And we're at the right size. So now what I'm going to do is, unfortunately, this I don't like these taps too much because this particular tap doesn't have the hole in the back of it. I don't have that alignment tool for a tap follower, you know, to line this in, because I'm not going to power tap this, obviously. So I'm going to reset this up, take this chuck out here because it's too big, and go with a collet with the tap follower, the spring tap follower, and we'll put her in a tapping handle that does have a hole in the back of it for that purpose. That way we can get it true lined up or as close as we need to run this tap down in here. It's just, unfortunately, one of these things. If it had a different tap, I just put the tap follower in and Bob's your uncle. This one we'll just put in with some anchor lube. Just preload this a little bit. Now we should be straight. Straight as we need to be. But make sure that you're pretty much lined up with it. Unless you want to power tap it or start it with a tap under power, which I don't really want to do in this situation either. These Time-Sert taps are wicked sharp too, so a brand new one is glorious to run through like aluminum here. Of course, you're not taking a ton of material out either. Gloria, glorious. I'm going all the way down until it starts to penetrate through because I just don't know exactly how much length, and it's not gonna hurt nothing. All right, I'm good with that. Drilled, counterbored, tapped. So we're ready for the final operation, which is, inserting the insert itself with the appropriate tool that they provide. This is the insert driving tool. Looks like a tap, but it's just got the screw thread, and the insert screws on like this. So you essentially just screw it on till it kind of stops, which it does pretty quick. But what they want you to use is they want you to use some light oil on the threads here, so on the inside of the insert. But if you're going to use some Loctite, you got to do that obviously on the outside of the insert. So you try to keep them as separate as possible. I think I would like to use a little Loctite on it, just a little bit. Some Time-Sert Loctite. This is a 60-20 Time-Sert Loctite. And we'll go ahead and do the same thing with the tap follower. That way we know we're nice and straight. So I'm just going to put a little bit of oil on my Time-Sert tool, my driving tool here. I've already cleaned the hole out with the brake clean and blowed it out. A little bit of this Loctite. I'm just going to put a little bit on. It's red Loctite. And all you do is just drive it in. Now what's going to happen is it's going to get hard and then it eases up. And as soon as it eases up, you're at the point where the insert is in fully. And it's just starting to get easy now. So now we're going to back it out. Maybe a little bit more. Yep. Now we're going to go ahead and back it out. I forgot to mention I used a 9.6 mil long insert. Those are the ones that come with it, and I also ordered some extra ones. I ordered some longer ones, but they're not here. It doesn't really matter because when you go to and do the depth of this hole, as far as where the threads would typically start, it's about 460 thou. So if you bring this down 460 thou from the surface here, this is about where the threads would start. So if you hold this up to there, you're almost right at the bottom. So this thing is about another 10, maybe 12 mil. So basically that's not bad at all. 10 mil is about 370 something. So if you're about 10 mil down from the bottom, from there, it's about equal, so because it starts about there and goes down. So you're about from this first fin down as far as the depth of the insert goes, and that's really about 10 mil down. So it's a 9.6 mil insert. I think it worked pretty well. Let's go ahead and take a look at it. So here's a properly installed insert. She looks real nice. And the top of the threads are probably about exactly the same as what the original ones were. They might be slightly prouder because those were kind of at the bottom of a taper, like I said, the head of a drill bit. But those are, more square, so they're a little prouder. So I think my initial thought of them actually being lower was wrong. And that's fine. There's plenty of room in there below the surface where our pin goes. So there's not a problem whatsoever as far as that goes. You can see that line in there where the pin would stop well above that. I ended up doing the other one as well because, why not? You're in situ, you might as well just do it. So that came out real good and I'm real happy about it. And I think customer will be very happy about it too because these are never going to strip out. Another way we can test this, which I just did, is just put the pins in, drop the cylinder head down, a cylinder block up on the bench here. And these guys go in perfectly. No problem whatsoever. These only get torqued to about 195 inch-pounds anyway, which is like 6 or 8 foot-pounds or something, which would be no problem for those Time-Serts. And they're plenty long enough. As you can see, you got plenty of thread engagement from up here. When the thread is no longer engaged, it's actually still engaged there. You pull all the way up, there's where it hits the thread. So you got pretty much the same as it was before, except this is a permanent repair of a lot sturdier threads than just going into the aluminums. All right, that's about it. I'm all cleaned up, ready to move on with my day and do some other things. As you can see from the video, I actually repaired both sides of that cylinder block. Even though the other threads were sort of good, there was a little bit of wiggling in there, and I'm sure the threads were a little compromised. So it's just inevitable. It's gonna strip out like the other one eventually, probably. So I figured why not just do both since I got the cylinder block off and I got the tools and I got the inserts. So that's what we did. So I hope you got something out of it. Hope you enjoyed it. Maybe picked up a few tips. Again, it was a good amount of detail in this one. That's why I wanted to break it out into a midweek machining video. Watch for video number 2 on the KZ1000, and you'll see where we put this cylinder block, cylinder head back into action. So as always, don't just repair, restore. Thanks for watching. Catch you on next video.